In this video, we're going to be dealing with a problem that will explain the idea of a weighted average. So the problem given is such. A teacher gave the same test to two classes. In the class with 50 students, the mean score was 76. In the class with 30 students, the mean score was 84. What was the mean score for all students? So on the screen here, the first thing you do when you're working with a word problem is you identify all of the information you're given. And in this case, for the first class, we're given the mean value of 76, and we're told that there are 50 students in the class, and I'm going to call those students A1, A2, up to N1. And in class 2, we're told that the mean score is 84, and that there are 30 students in the class, and I will call them students B1, B2, up to BN2. So what we really want to find is the mean score for all students. So if we had the individual scores, we could add up all of the scores from class 1 plus all of the scores from class 2 divided by the total number of students there are, which is N1 plus N2. Okay, but unfortunately we are not given that information, but we are given the other information that we can use in order to solve it. So what we are given is the mean, and if we take a look, the mean value is equal to the sum of the AI values from I equals 1 to N1 divided by N1. So this is equal to A1 plus A2 plus dot 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 up to AN1, all divided by N1. Now if we multiply all sides of this, this will give us N1 times N1, which is equal to A1 plus A2 plus dot 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 up to AN1. So here, as you can see, we weren't given the individual test scores, but we were given the information in order to find the sum of the test scores, which is all we really need for the value. As you can see here, all of this, which is equal to this part here, will fit in right here, and then we're also given this little piece of information here. So we got the first part, so now all we have to do is find out the second part, which is the blue part here for class 2. So from here, we can do the same thing. We can find the score here, and I'll use J for this one. And this, divided by N2, and this will give us B1 plus B2 plus dot 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 up to BN2, all divided by N2. Now this, if we multiply both sides of this equation by N2, this will give us the following. Plus B2 plus dot 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 up to B and 2. So now we're given the sum of all of the student scores in the second class, which is equal just to the mean of that class multiplied by the number of students in that class. So now we have this part of our equation. So now we can take the information we have gained here and put it into the formula right over here. So I'm just going to move everything up a little bit so that we have a little bit more space. So now, going back to our original equation that we're looking for, so we have x bar overall is equal to x1 bar times n1 plus x bar 2 and 2 all divided by n1 plus n2. And here we're given all of the information. So take the information we're given, which is 76 times 50, just put a whole bar here, plus x bar 2, which is 84, times n2, which is 30, divided by 50 plus 30. And if you do the math on that, you will see that your answer is 79. Right. So that's the answer. Now, so I also want to give you a better sense of just why that is the case here. And I'm just going to do that by a little bit of algebra here. Okay. So if we took this original formula here, so we have x bar overall equal to x1, n1, and I'm just going to divide this formula up into two parts here. So we're going to have that plus our n2 over here, added with our x bar 2 and 2 divided by our n1 plus n2. Now if you take a look at this formula, you will notice that there is a ratio here. So we have a ratio over here, and we have one over here. Now, this ratio over here tells us the proportion, kind of tells us like the weight that we want to give to the average in the first class, and this one tells us the average that we want to give to the second class. Now you'll notice that if we had n1 equal to n2, so if both classes had the same number of students in here, then we could actually use just the mean of the means formula. So that would just be x bar 1 plus x bar 2 over 2, and it would work. However, here we have different number of students in each class. So this one, we're actually taking the mean of each class, multiplying it by its weight, which is the proportion of students that it has from the overall total of students. So here, we're going to have x bar 1, and we're going to have this multiplied by n1, which is 50 over 50 plus 30, which is 80. And we're going to also have this second part, which is going to be x bar 2 times 30 over 80, where the 80 on the denominator is just the sum, or the total number of students in all the classes. So as you can see, if you add up 50 over 80 plus 30 over 80, you're going to get 80 over 80, which is 100%. So here we're giving a portion to our overall mean to our first class and another portion to our second class, and we're deciding on that proportion based on how many students are in each class. A class that has more students in it should be given more weight. So as an example, let's say we're given another example here. Okay, let's say we have another example where we have class 1 and class 2, and again we'll have x bar 1 is equal to 76, but this time, let's say n1 is equal to 95, and x bar 2 is equal to 84 as well, but this time n2 is equal to 5. So we have one class that has 95 students, and another class that has just 5 students. So in this case, it's a little bit more obvious, but we should definitely give more weight to class 1. And since they have 95% of the students out of the total, because here we have n1 plus n2 equals 95 plus 5 equals 100 students, then we should give 95% of the overall average of both classes to class 1 and 5% to class 2. So that is my example for how to understand weighted averages. I hope it was useful.